In this example, we will find the solution of the initial value problem y double prime minus 4y prime plus 13y equals 0 with the initial conditions y of 0 equals 1 and y prime of 0 equals 8. To solve an initial value problem, we first find the general solution of the differential equation. To start this, we'll solve the characteristic equation r squared minus 4r plus 13 equals 0. Since this can't be factored, we can use the quadratic formula to find the roots. The roots r1 and r2 are negative of negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 13 all over 2 times 1, where the discriminant, what's under the square root, reduces to 16 minus 52, which is negative 36. So we have 4 plus or minus the square root of negative 36 all over 2. And the square root of negative 36 is 6i, so our roots simplify to 4 plus or minus 6i over 2, which reduces again to 2 plus or minus 3i. Now using the root r equals 2 plus 3i, we have that the general solution is y equals c1 e to the 2t times cosine 3t plus c2 e to the 2t times sine 3t. Now that we have the general solution, we need to impose the initial conditions. Using first that 1 equals y of 0, and on the other hand that y of 0 is this function evaluated at t equals 0, which is c1 times e to the 2 times 0 times cosine of 3 times 0 plus c2 times e to the 3 times 0 times sine of 3 times 0, which can be simplified because e to the 2 times 0 is just 1, cosine of 0 is 1, and sine of 0 is 0. So in total, the right-hand side of this is just c1, and we have that c1 is equal to 1. To use the initial condition that y prime of 0 equals 8, we need to compute the derivative of our function y using the product rule. Doing this gives that y prime is 2c1 times e to the 2t cosine 3t minus 3c1 e to the 2t times sine 3t, coming from the first term of y, plus 2c2 e to the 2t sine 3t plus 3c2 e to the 2t cosine 3t, coming from the derivative of the second term of y. Evaluating y prime at 0, we get that 8 equals y prime at 0, which is 2c1 plus 3c2. And using that c1 as 1, this reduces to 2 plus 3c2, which gives c2 equals 2. Using these values of c1 and c2 in our general solution, we can conclude that the solution to the initial value problem is y equals 1 times e to the 2t cosine 3t plus 2 times e to the 2t sine 3t.